The story starts earlier this year when my computer died. I got to borrow a very old, low-spec 2015 MacBook Air from one of our investors, and that turned out to be a blessing in disguise because what happened around that time was that Matter Labs released Zinc, and I started experimenting with Zinc on this old MacBook Air, and I was blown away by the performance. Even on this old computer, it was lightning fast. So here's a scenario. We are organizing a online puzzle contest. The first person to solve our puzzle will win the first prize. The second person to solve our puzzle will win the second prize, etc. So it's important that the contestants are able to prove that they have solved a puzzle without disclosing the solution of the puzzle. Now, let's take a very easy puzzle that nobody will ever use for an online contest, and it's called a magic square. The way it works is that the sum of all rows is 15, the sum of all columns is 15, and the sum of both diagonals is 15. So let's build an app for this scenario, an app that can verify the user's solution and publishes the proof of a correct solution on a blockchain. This is a clean computer, and I can show that by typing in Zargo, which is the cargo equivalent of Zinc, which is not there. The only thing I need to do to install the tools, which is Starling Studio, the IDE, and VivoPay, which is the wallet, is simply drag them to applications. That's all there's to it. Let's open Studio. It comes internally with an internal version of Zinc, both the compiler and everything you need, including VM. You can also use an external version. There's none here, of course, on this computer. So we're going to use the internal version. What comes with Starling Studio is a number of example projects. So, for example, proof of hash preimage. Let's call this zkSummit demo and create the project. So this is an example you can simply run, and you'll see all the results here on the bottom of the screen. So what is happening is that what we try to achieve is to make it as easy to understand as possible for new users. The interface you see is not the final version yet, but you can kind of see, we're trying to explain what a witness is, what the public output is, and the way it works, by the way, in Zinc, is that there's one main function, just like C, for example. The inputs here are the witness, so that's the data that you're not going to share, that you keep secret. You're not going to share that with the verifier as a prover. The output is public output, which is the input used by the verifier. So the output as a prover is the input you need for the verifier. So we've created a new project, an empty project, and that will be our puzzle app. The idea is that the user will pass their solution, which is an array of 9 integers, as a witness into the application, and the application will check whether that 9 digits is the solution or not a valid solution. The way we're doing it is using asserts. There are many ways of doing it. In our case, how it will work is that the app will only produce a proof if the values are the values we're expecting. So what you notice is that Studio automatically parses the code. So in the right bar, automatically you can see the 9 elements and the 9 items of the witness automatically generated by Studio. So here we're adding the asserts. I'm going to skip a little bit here because it is pretty clear, I guess, how that will work. There we are. We can interact now with the code, but there's one issue, and the issue is that if I generate a valid proof, everybody can copy the proof from that moment on. So what we need is a kind of way to link the output to me and me only. And the way we do that is to add a ID to the witness that also will be the public output, and that is the public input to the verifier. That way, nobody can copy the solution. We can check that. So what we can do is change the input, the verifier, and see if it still verifies, which it will not. Now, how will the user interact with this? Simply through the wallet. You can start the wallet and pass the zero knowledge application to the wallet. And apologies how the wallet looks like. It's a originally mobile wallet, and not all user interface elements came through correctly. But as you can see, the wallet has applications built in. I've cheated a little bit here because I already created the interface beforehand. So what we've seen is not ready for production yet, but it does show it's possible. And the most important takeaway for me is that it is possible to offload general computation from the miners to the edge nodes, meaning wallets. And if we do that, we can have a blockchain architecture that's not only scalable, but also much more private than current blockchains. If you have any questions, this is my email. Feel free to contact me. I'm happy to chat more. Thank you.
Cool. So let's take it all. I don't know if there are any questions right now in the chat, but I know that I have a question. In the case of this work in Starling Studio, are there any parts that you feel like are still kind of like untouched, things that are missing somehow in the build?
Yeah, I mean, there are parts missing still. The biggest part that's missing is the verification on chain. So the way we envision it, like in the first place, is something similar to Socrates, in that you have a smart contract produced as a verifier by the meaning compilation step by the developer. That's not happening right now. That's not finished yet. And the other thing is Zinc itself is still in development, as we've seen in the previous presentation by Alex. And there's a lot of things that are in development there as well. Yeah.
Cool. So how far along is the project?
We have the demo working as you saw. There's still a lot to do to make it ready for production, and that's both on our side and a part of Zinc, for example. Because right now there's a trusted setup in the demo that of course cannot happen in the real project.
What is the connection between Matter and the work you're doing and sort of Starling Protocol?
Mm-hmm. So there's none non-official, at least. I mean, I met Alex earlier this year at the cool. I think it was the Stanford conference.
Yeah, I was there too.
And yeah.
The last time we were all together, actually, in person.
Yeah.
Wild.
Completely different world back then. So no, I mean, I like the. This was the first time I saw a language that had almost everything built in to do a smart contract. Was easy to use, was performant, and what have you. Afterwards, Aleo came on the scene. But yeah, I mean, Zinc has everything that we kind of needed for this project. So that's why we use it. But there's no official link between Starling and Meta Labs.
Cool. Well, thank you so much for the presentation, Ronald.
Thank you. Thank you for having me.